On your videos. Sharat.
Sir.
If I rotate mirror by theta degrees clockwise direction, the reflected ray will rotate by
Just 2 minutes.
huh? Tanvi. Huh? 360 by theta minus 1. Lahita. If I rotate by theta clockwise direction, the reflected ray will rotate by Lahita on your video. Everyone on your video. Darshan, if I rotate mirror by theta degrees clockwise direction, they will rotate by
Nothing, sir.
Vajra, Nikita, Lahita, Sanjay, Arshad, on your videos. Shashank.
Yes, sir.
If I rotate the mirror by theta degrees clockwise direction, the reflected ray will rotate by
Counterclockwise.
mute your microphone. Dhruvesh. Vajra.
Yes, sir.
Same question.
2 theta.
2 theta in the same direction or 2 theta clockwise. Good. If I rotate ray by alpha in clockwise direction, the reflected ray will rotate by
Alpha in the opposite direction.
alpha counterclockwise direction. Sharat, no, I'll ask Tanvi. Tanvi, if two mirrors are placed at an angle theta and I'll say not theta at an angle 60 degrees and the image is placed asymmetrically, then the object is placed asymmetrically, then number of images formed are can you be a little louder? See, I'm taking two mirrors which are placed at an angle of 60 degrees with each other. Now I have taken a point object, and that point object from one mirror it is at 20 degrees and the other mirror it is at 40 degrees. Then the number of images formed are Ajay?
Sir, 5.
5, yes. So you will use the formula
360 by theta
-1.
-1.
Yeah.
That formula should be used.
Huh?
I got confused.
Satraji, if two
Yes, sir.
plane mirrors are made at an angle of 83 degrees with each other,
Yes, sir.
then the number of images formed are
360 by 83, which is
360 by,
83.
is it 360 by 83 or 360 by 83 -1?
No, it's 360. It's odd and it's asymmetrical. So it's the last one. So it's only 360 by theta.
Correct. So, okay. I think these questions I have given yesterday as homework, right?
Yes, sir.
Yes.
Okay. So this I told you to fill the reflector here. Hope you have completed that. So now let's see spherical mirrors. See, we have seen plane mirrors. In plane mirrors, we have seen how your image is formed. And in plane mirrors, the image formed is whatever laterally inverted, same size, same distance, isn't it?
Yes, sir.
Yes, sir.
Now, that's a plane mirror. But what if the mirror is at an angle? Okay. So there are two cases in spherical mirrors. The one case is your concave case. The other one is your convex case. Okay. Now, see, concave means, for example, if I take a circular mirror, if I take a circular mirror, this is a circular mirror, and now I take a knife and cut the mirror in this fashion. This is the part which you'll get from that.
Yes, sir.
Right, so you take a circle, you cut a part of this. So this is something which looks like this, isn't it?
Yes, sir.
Now, if inside you have your reflecting surface, then that is called as your concave mirror. Okay. Now, if I take a knife, I cut this portion of it, then I get something like this. And if you are outside, which is there, this is your reflecting surface. Then this is called as your
Convex mirror.
convex mirror. Clear?
Yes, sir.
Now, the terminology which we will use for spherical mirrors is, the first one is your center of curvature. So the curvature is, see, this concave mirror is part of a circular mirror, isn't it? So
Yes, sir.
inside the circular mirror, you have a center point for that circle, isn't it?
Yes, sir.
That center is called a center of curvature. Just hold on for 1 minute. Okay. Yeah, that was Karnataka government wanting to know my status. So that's called as your center of curvature, right? Now, what do I mean by pole or vertex? Okay. The center point or the midpoint of your spherical mirror is called as your pole or vertex. This P which is there, this is called as pole, and here for convex, this is called as pole. Okay. Then radius of curvature, the distance between the center of curvature and your pole is called as radius of curvature. The distance between your center of curvature and that's basically, see, this distance. This is radius, you already know that. This distance, you already know it's radius. So that's just radius of curvature. Put off curvature of the radius, it becomes just radius. Next is your principal axis. The line joining the center of curvature with the pole is your principal axis. Principal, not principal. Principal axis. PAL, principal axis. Normal, you already know, and aperture, that's okay. Aperture is not bigger, but diameter outline is your aperture. Okay. So now, before going further, put your heading as sign convention. Please remember, we will be going for your Cartesian sign convention. Okay. So if you take pole as your origin, anything which is going towards the right is taken as positive and towards the left is taken as negative. Anything above the pole, that is above the principal axis, is taken as positive and below the principal axis taken as negative. So it is just like your Cartesian coordinate system, x minus x, y, y. Okay, somebody will take it like this. If you are going in the direction of incident ray, they will take it as positive. If you are going in the opposite direction of incident ray, they will take it as negative. Okay, that is another kind of sign convention which others follow. But what we will be following, you under my will be following Cartesian sign convention. So whenever you are trying to solve your numericals, you have to clearly mention the sign convention. Clear? You have to very clearly mention the sign convention. you have to say, I am adopting Cartesian sign convention. Okay. If you are not comfortable with Cartesian sign convention, for example, to say in the direction of incident ray, I am taking it as positive. In opposite direction of incident light, I am taking it as negative. Mention that also. Anything you have to mention your sign convention. Okay. Generally, Cartesian sign convention is easy to follow because it's easy, right? X minus X, Y and minus Y. You have been in mathematics for a very long time, right? So generally, we will be taking Cartesian sign convention. Okay.
Yes, sir.
Now, okay, this is little different. I'll go to this. Now here, see, your rays are coming parallel to principal axis. Your
Yes,
rays
sir.
are coming parallel to principal axis. Whenever the rays are coming parallel to principal axis, all the rays will go through your focal point. Now, what do I mean by focal point? Say, for example, you know, according to law of reflection, if this is your surface, immediately first you will draw a normal to the surface. Incident light, when it is falling like this, say it is angle of incidence, right? To get your reflected ray from here, at this point you will draw a normal.
Make the same angle.
You will draw another ray. This is called as your reflected ray, isn't it? The same.
Yes, sir.
If a parallel ray is coming and hitting at this point, draw a tangent and draw a normal. Understood? Is it clear?
Yes.
Yes, sir.
At this point, a tangent and a normal. At this point, a tangent and a normal. At this point, a tangent and a normal. At this point, this point, this point. So if you draw tangents at every point and the normals at every point, all these normals will come and meet at your common point called as focal point. Okay. So whenever your rays are going parallel to your principal axis, they will always come and meet at
1 point.
focal
Focal point.
Focal point.
Clear? This is in case of your concave mirror. Clear?
Yes, sir.
Now, in case of your convex mirror, at this point it is coming and hitting. So at this point I'll take a tangent and at that point I'll take a normal. So as I said, any ray which is passing parallel to principal axis has to go through your focal point, isn't it?
Yes, sir.
So, but here what happens is, if you take a tangent and a normal, you go like this and gets reflected and go in this direction, right?
Yes, sir.
So if you retrace this ray backward,
Till the focal
point. If you retrace this ray backward and this and this like this, you will get a focal point. So for a concave mirror, the focal point is on left hand side of your mirror, and for convex mirror, it is on the right hand side of your mirror. The others, this is one. Second important point, your concave mirror is also called as
converging mirror.
converging mirror, because you can see all the light rays are converging. Your convex mirror is called as
Diverging mirror.
diverging mirror. because all your light rays are direct. Clear?
Yes, sir.
So concave mirror, you will get a real image or a virtual image.
Can't
Real
clear.
image.
Concave,
Real image.
real image, and we'll see that later. We will see. Okay, I'll be giving you all that thing. Understood now?
Yes, sir.
So you understood the tangent and all, right?
Yes,
Clear?
sir.
Okay. Now, what do you mean by principal focus? I just told you right now, right?
Yes, sir.
Yes, sir.
So take down this definition. And then after that, you okay. First, take down this definition, principal focus. April and May mains is postponed. I don't know when they will conduct it again. Over?
1 minute, sir.
See, all this I think in the 10th standard you have studied, right? Mirroring you have studied.
Yes, sir. Yes, sir.
Yes, sir.
Lens maker's formula.
Which one?
Lens maker's formula.
So is it 1 by f is equal to 1 by v of the space?
And one by
Yes. Over?
Yes, sir.
So what do I mean by focal plane? Okay, first of all, take this. The next line, the distance between principal focus and pole is called as focal length. The distance between focus and pole of the mirror is called as focal length. And then take down focal plane. First, I am sending this PPT. Put your head like a focal plane and then use some spacing there. Then put your head like this focal plane and use some space. Okay. Now let's see what is your object and what is your image. And then however the image is form of the objects placed at different distances from the mirror, right?
Yes, sir.
So an object is something from which your light rays are coming, right? And when light rays are coming and they are falling on a concave or convex cylinder, they either converge or diverge depending on what kind of weather. So and then all these rays will converge at one point and will get an image of transposition. But if your object distance is changing, then your nature of the image also changes. Okay. If your object distance from the mirror is changing, then the nature of the image also changes. Now, how does it change? The image is very visible. Okay. So how does it change? When the object is changing, this is what we will see something like that. Okay. So this is your concave mirror. Right. So I have putting important points. C is called as your F is your
Focus point.
focal point. B is your now I identify image to the object will be at an infinite distance. When an object is at infinite distance, and the licenses that are coming will be parallel to the principal axis.
Yes.
So I said when the parallel to the principal axis comes, it will go to
Focus.
focal. So when it and then they when you are reflected, then you go focal point, right? But here is can I get an image? I cannot get an image, right? Now I have to take another meeting incident, right?
Yes, sir.
So I'm making an incident passing through your center of reflection. And then I have to go to central axis, right? So, right? So if I get the ray exactly reflected back,
Yes, sir.
right? So where is the image from?
And focus. Focal point.
Yes. Clear. So take down this. The light will parallel to principal axis. When reflected, it will go through focus. Next, the light will pass through center of curvature, will reflect 180 degrees and again pass through center of curvature. Which passes to center of curvature, they reflect 180 degrees and again will go to center of curvature. Third important point, light ray passing through focus will travel parallel to principal axis. If you know these three, you can get images. Okay. Shall we go now?
Yes, sir.
So, see concave mirror. Said I'm first taking your object is placed beyond of curvature.
Yes, sir.
So if it is placed beyond center of curvature, the light rays which are coming will be parallel to your principal axis.
Yes, sir.
Right? It's going through focus, right? Now I have to take another light ray. So what I'll do is I'll take another light ray which is passing through focus. It will now go through.
Is parallel
Will be
to
parallel to
principal
the
axis.
first one. Yes, sir.
So this light ray reflected and this light ray reflected will meet at this point. So that is how your image is formed.
Yes, sir.
Clear?
Yes, sir.
So whenever the object is placed beyond center of curvature, the image is formed between center of curvature and focal point. Yeah, inverted and diminished.
Yes, sir.
Inverted and diminished. Okay.
Yes, sir.
Now, if your object is placed at center of curvature, if your object is placed at center of curvature, now what I'm going to do is I'm going to take the same concept. A ray is in parallel to principal axis. It will go through your focal point. And then a ray going through your focus will go parallel to your center of curvature. So your image is formed at
Center of
Center of
curvature.
curvature.
inverted and same. Okay. See, instead of that image, just take an arrow and then do it.
Yes, sir.
For example, instead of that, an object something like this, center of curvature, focal. So it goes like this, goes from focus. Yeah, thank you. Go. Close the door now. Yeah. So it's formed here. Okay.
Yes, sir.
Your ray diagrams are very important because that's actually how you will understand it. Now,
Yes.
if the object is placed in between your center of curvature and focal point, one ray is going parallel to principal axis will go through focus. Other ray will go through focus and go parallel to your principal axis, right?
Yes, sir.
So your image formed is
Inverted and
Inverted.
and it is beyond C.
it's beyond your center of curvature. Okay. The next one. If your object is placed at the focus, Now, since I cannot take a ray passing through your focus, I'll take the ray passing through your pole.
Yes, sir.
We'll never get.
They will never
They will never meet.
meet.
You won't have any reflection.
Correct.
Image.
Clear? Next, convex.
1 minute. Steve. Thank you. Sir.
See, at pole, draw a tangent, draw a normal. It follows the law of reflection, isn't it? That's
Yes.
how you get your parallelness. Next, convex mirror. Okay. Convex mirror will take first condition. The rays are coming from infinite position. So we know they will meet at your rays
point.
parallel to your principal
Focal point.
Yes, sir.
point. Okay. Now, if your object is placed at certain distance from your pole, finite distance, I'm going to take a ray which is going parallel to principal axis. So it will reflect in that direction, right? I'm going to take another one which is just falling on one point, right? So this ray is actually coming
Passing
from
to the focus.
coming from the center of curvature, right? Any ray passing through your center of curvature will also go through your center of curvature.
Yes, sir.
180 degrees, right?
Yes, sir.
Yes, sir.
Now, this ray will meet at focal point, right? If I retrace it back, it appears as if it is coming from your focal point, isn't it?
Yes, sir.
Yes,
Yes,
sir.
sir.
And this ray coming from your center of curvature. So you have a virtual image but diminished. Did you understood the ray diagrams? Because ray diagrams, if you understand, everything else is very easy. Clear?
Yes, sir. Yes, sir.
Is it over? Shall I?
Yes.
Yes, sir.
Yes, sir.
Here. Take down this table. Over.
1 minute, sir.
On your videos, everyone, Tanvi, Sumukha, Kavya, Shashank, Nikita, Lahita, Shrat, Sanjay, Sanjan. Oh my goodness, every time I have to call your name and then only you will do it. Sharat, Vajra. Rishikesh, Jaydeep, Arshad, Varsha, now the class looks lively. See everybody on your video, I can see what you are doing and everything. Is it over?
Yes, sir.
Okay. So next, put your heading as relation between focal point and radius of curvature, concave mirror. Now see, for that what I am doing is, I have taken a concave mirror, okay, and I have taken your object which is placed at infinite. You will get a ray which is parallel to your principal axis, and that will go through your focal point, isn't it?
Yes,
Now
Yes,
at
sir.
this point, if I take a tangent and if I take a normal, according to law of reflection, angle of incidence is equal to angle of
Reflection.
reflection.
So if this is theta, this becomes theta, isn't it?
Yes,
Yes,
sir.
sir.
If this is theta, this one, this becomes theta.
Parallel. Interior angles are parallel.
Line with this line, it is making a theta. This line with this line makes an angle theta, right?
Yes, sir.
The same line and parallel lines. So this is an angle theta, right?
Yes, sir.
Now what I'm telling is, I need a relation between radius of curvature and focal length, right? I know the curvature is distance from your center of curvature to pole, and your focal length is from
Focal.
principal focus to pole, right?
Yes, sir.
Now see, from here, for this line perpendicular, I am dropping it to principal axis. So that call it as P dash. Okay.
Yes, sir.
Now, please understand your P dash is very small. Okay. Your P dash is very small. Now, see, if this total angle is 2 theta, then this angle is 2 theta.
Yes, sir.
Theta plus theta, so hence this will become 2 theta. Isn't
Yes,
it?
sir.
Yes, sir.
Now, see, I'm going to take my triangle QCP. Since P dash is very small, I will say my P dash and P, they are very near to each other. So P dash is approximately P. Okay. I'll take my triangle QCP. From triangle QCP, your tan is QP divided by CP. Now I'm going to take my triangle QFP. From that, tan 2 theta is equal to QP divided by FP.
Yes, sir.
So for your theta's very small, your tan theta approximately.
Theta.
So I know theta is QP divided by CP. And I know 2 theta is QP divided by FP. So 2 times of QP divided by CP will become QP divided by FP. So QP gets cancelled. From this C will become CP by 2.
Yes, sir.
FP is nothing but your focal length,
Yes, sir.
and CP is nothing but your radius of curvature.
Yes.
Yes, sir.
So from that we get a relation. Your focal length is half of your.
Radius of curvature.
This goes into your formula. A very simple derivation. Very, very simple. Actually, ray optics, I told you, everything is mathematics only. Everything is straight lines and angles. Actually, ray optics is far, far, far easy when compared to wave optics. Since you have mastered wave optics, ray optics should be a piece of cake for you. What more?
So sometimes you scare us that it is hard, and sometimes you're telling us.
See, every one of you have come to your PU with an ideology that physics is very difficult. Correct? So that's why when you have that ideology of physics is very difficult when you came to PU, even the easiest one looks like the difficult one. Solve numericals yesterday. Is there anything related to optics there other than mathematics?
No, sir.
When we come to refraction, then we'll come to optics part. Or else everything is your mathematics only, right? Is this over? The only problem in your ray optics is time gets consumed for drawing the ray diagram. Oh. What, Ajay, ray optics is over for you?
No, sir.
Okay. Everybody, you are able to, if you didn't understand, you ask me, I'll explain again.
Understood, sir.
JD, Varsha, Sumukha, your name itself is Sumukha. Very good face. You have to on your video.
Yes, sir.
Right. Done? Similarly, if we take your convex mirror, let's see if your radius of curvature and focal length have the same relation or is it different relation. For that, again, I'm going to take my ray which is coming parallel to your principal axis. Okay, comes, hits at this point. So at this point, I'm going to draw a tangent and I'm going to draw a normal. Normal, how much this is making? The same angle it will make here. So the ray is getting reflected in this direction. Okay? Clear?
Yes, sir.
Now, this I'm going to retrace it. So it appears to be coming from
Okay.
focal.
Focus.
This normal, if I just take it, extend it will be coming from
Center of curvature.
center of curvature, right? With this, it is making angle I. So this with this makes an angle
Yes,
I.
sir.
Yes, sir.
This is R. So this is R.
Yes, sir.
Yes, sir.
Right. This total is I plus R. So this will be I plus R.
Yes, sir.
And I and R is equal. So ACB. Angle ACB. So it will be tan I is equal to AP by
ACB.
and then take an angle AFP.
Tan 2I is
Equal to
APIFP.
AFP. Similarly, by CP.
Equals APIFP.
AP gets cancelled. From that, FP is equal to
CP by 2.
so all else FP is your So whether it is convex mirror, whether it is concave mirror, your focal length is always equal to half of the curvature.
Yes, sir.
Take down the ray diagram and also the derivation. Srikant,
Sir.
ఎవరైతే వీడియో ఆన్ రాసుకొని I want to copy their parents too.
Okay.
So suddenly every video got on now. Until and unless you are doing some unparliamentary activities on your side, I don't want you to off your video. Is it over?
Yes, sir.
Do not look at this. If you have understood it, please draw the diagram on your own, because that is how your ray optics you will get. Ray diagram you have to draw very clearly. You have to know. Now tell me, if my ray and falling, coming on this normal, how does it go?
It will go
It
back
like
to the
goes in
same
the same direction.
Yes, it will go in the same direction in 180 degrees, right?
Yes, sir.
Yes, sir.
Please remember that. Very important. Is it over? Shall I go to the next one?
Yes, sir.
So, okay. Next, let's come to something called as your Miller equation. Okay, the Miller equation will give you the relation between your object distance, image distance, and focal point. Okay, so why it is Miller equation or lens equation or everything? Because see, many of you have spectacles, right? So these are your lenses basically. If anybody have sight, called as your lenses. Okay, so we will be seeing in your lens. See, what do I mean by you have eyesight? First of all, okay. Now that I have taken my specs, if I'm going beyond 25 centimeters, which is called as your normal vision for this normal distance for distinct vision. Okay. Now, if I see, I'm able to see everything very clearly at this distance. But when I go to this distance, now I'm starting to see slowly blurred kind of images, not clear images. Okay. That means there is some aberration for my eyes. That means image is not falling exactly on retina, isn't it? Now what I'm doing is, when I put my specs like this, now the rays which on my eye are exactly converging and falling on my retina. Right? Now see, when I remove this, when I put this, my object distance is same.
Yes, sir.
But my image is being different, right?
Yes, sir.
So now when I'm telling like that, I'm talking about my object distance, right? I'm talking about my distance.
Yes,
I'm talking about my lens. So the lens is characterized by its power. Power is nothing but inverse of focal length. Okay. So basically the lens is characterized by the lens focal point. Similarly, the mirror or spherical mirror is characterized by its focal point. Clear? So that's the reason why it is very to understand the relation between your focal point, image distance, and object distance. Clear?
yes,
Now
sir.
you understood why you are studying your mirror equation and lens makers formula and everything. Now, what I'm going to do is, I'm taking a concave mirror. Your principal axis. So this is where you get your image. right? This is your pole of your mirror, vertex or pole. Now, the distance of the object from the pole is called as your object distance. The distance between your object and your pole is called as your object distance given by u. Okay. The distance between your image and the pole is given as your image distance represented by v. Please understand your object distance is always u and your image distance is always v in your ray optics. The distance from your focal point to your pole is your focal length, right?
Yes, sir.
Now I need the relation between u, v and f. Clear?
Yes, sir.
Shall we do it?
Yes, sir.
Okay, so take this diagram. So from B to pole is your U. From here to here it is your V. From here to here it is your F. Now what I'm going to take is, I'm going to take my triangle ACB and I'm going to take my triangle A1, B1, C, right? This angle is equal to this angle.
Yes, sir.
Right?
Yes, sir.
This is 90 and this
That's
is
also 90.
right.
Yes, sir.
90, 90. This angle same. So this angle
It's also same.
And is all that
is
is
the
also
same.
same.
Yes, sir.
Yes, sir.
Right? So now this becomes like a similar triangles.
Yes, sir.
So can I say AB by A1 B1 is equal to
B1C,
divided by
B1C. Yes, sir.
Now you may ask me, sir, why is that you are taking these two triangles? Okay, because this is object, this is image. So I'm trying to get the relation between your distances of your object and images. Okay, now I need the distance of focal point, right? For that, I'm going to take my triangle FDE. Okay. And I'm going to take my triangle F, A1, B1. If this angle is theta, this angle will also be theta.
Yes, sir.
This is
90 and 90.
This is also 90. So this angle will be equal to this angle.
Yes,
And
sir.
those also will become your similar triangle.
Similar triangles.
Right? So again, ED divided by ED divided by A1
B1.
B1 will be equal to
EF by
E divided by A1 B1 is equal to EF
EF by F.
divided
B1
by
F.
EB
B1 F, sir.
FB1.
Yes, sir.
Until this it's over. draw this diagram and write this derivation. We are still only halfway of derivation. Over.
Yes, sir.
Now, see, your ED is equal to AB,
Yes, sir.
right? So that relation I'm going to take it and then I'm going to write it as AB by A1 B1 is equal to EF by FB1.
Yes, sir.
Right?
Yes, sir.
Yes, sir.
Now that I'm writing it as 1, 2, and the first one I've written it as 1. So you combine 1 and 2, you will get BC divided by B1C is equal to EF divided by FB1.
Yes, sir.
Any doubt?
No, sir.
No, sir.
Now see, this D, this E are very close to P I will consider. This E and D, I consider them to be very close to your pole because see the distances are very minute, right? So my EF will become PF. Look at your diagram. EF will become PF.
Yes, sir.
Yes, sir.
I'm going to rewrite it. BC divided by B1C will be equal to PF divided by FB1. Clear?
Yes, sir.
Right? So now, what is BC? PC minus
B.
yes. I want to take it like that. Then similarly, what is B1C? B1C. PB1 minus
CB.
and FB1. Oh, okay. FB1 will be PB1 minus PF.
Yeah.
I'm going to substitute them here. PC minus PB divided by PB1 minus PC is equal to PF divided by PB1 minus PF. Okay.
Yes, sir.
Now see, this C is your center of curvature, isn't it?
Yes, sir.
Yes, sir.
So I'm taking my sign conventions. PC will become minus radius of curvature.
Yes, sir.
Yes, sir.
PC. PF.
Minus here. Focal length.
Right? So this is what I have written here.
Yes, sir.
right? So now substitute in the above equation. U is also minus. U is not positive. It is on the left hand side, no?
Yes,
U is also minus. Clear? So PC is minus R minus PB is minus U divided by, I'll write it here, it will be easy. Minus R minus of minus U divided by PB1 is minus V, PC is minus R is equal to PF is minus focal length divided by PB1 is
Minus B minus F.
So this will become U minus R divided by
R minus V.
R minus V is equal to, I think minus common, this will become V
F
minus,
minus V.
huh?
V by V minus.
Minus F
Yeah.
by F minus V.
B minus F.
Minus I'm taking common, minus minus
Okay.
gets cancelled,
Yes, sir.
right?
Yes, sir.
Yes, sir.
Over. Rearrange the terms, you'll get 1 by V plus 1 by U is equal to 1 by U. Don't look at here in your notes, you do your derivation. In that, rearrange your terms and use your radius of curvature is equal to 2 times of focal length. We have followed your Cartesian sign conventions, okay? Do not forget that.
So for board exam, will they ask this derivation?
Huh?
Like for board exam, will they ask this derivation?
Board exam is next year. They have deleted syllabus or they have every syllabus. I don't know, right? It's too early to tell now. Because your seniors has deleted portion. But in ray optics, I don't even remember what is deleted. Anyhow, see, don't talk. Who talked about board examination?
Sumukh.
I'm going to kill you, Sumukha. You're all NIT, IIT aspirants. You should not talk about board. You have to learn everything. Clear?
Yes.
Next time from your class, if I hear board word other than whiteboard or blackboard, I'm going to kill you. You're all targeting IITs and you're talking about board. Over?
yes, sir.
Now, this also goes into your formula book, mirror equation. Now you got 1 by U plus 1 by V is equal to 1 by F, right? When you are solving your numericals, okay, you have to take appropriate sign conventions. You cannot say, sir, do you remember in derivation I have taken already sign convention? I have already included sign convention and got my formula. Should I again use sign convention? Yes, you have to again use sign convention. Clear? Any doubt in this?
No, sir.
Now, okay, we'll do this next 2 slides and then we'll try to solve some numericals on spherical mirrors. Now, what do I mean by linear magnification? Okay, linear magnification, why ratio came? No. Linear magnification is the ratio of height of the image divided by height. Okay, I'll take it as height of the image divided by height of the object. This is called as your magnification. Here also appropriate sign conventions we will take. Okay.
Yes, sir.
Now, when you're calculating magnification for mirrors, after taking appropriate sign conventions, if you are getting magnification as negative, then your image is
Real.
real. Because if you remember your concave mirror, object is above your pole and image is below,
Below.
right?
Yes, sir.
Yes, sir.
Your magnification will become minus.
Minus.
Concave mirror is a converging mirror, and what we get is a real image, isn't it?
Yes, sir.
So this also goes into your book. Magnification is height of the image divided by height of the object. If you want, take it as height of the image divided by height of the object. Okay. So if somebody says my magnification is positive, what is the nature of your image?
Virtual.
Virtual.
And somebody is telling your magnification is negative, then it is,
Real.
Real.
and this is virtual image. Clear? Plane mirror, what is your nature of image?
Virtual.
Virtual and same size,
So,
laterally inverted.
so M is equal to 1.
Yeah. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
If your M as less than 1, that means
Diminish.
the height of the image is less than your height of the object. So that means it is a diminished image. If your M is greater than 1, that means your height of the image is greater than your height of the
Object.
object. Clear? Now see, height of the image by height of the object into length of the image by length of the object. Right? What do I get? Area of the image by area of the object. We'll do numericals anyhow. Okay? So that's
Yes, sir.
not linear magnification in terms of your spherical mirror. Clear?
Yes, sir.
So I don't think you need this relation between MFV and MFU, right? Can you get it? Or do you want to derive it also? What? Okay. Anyhow, put your heading as relation between M, F, and V. We'll get M is equal to F minus V by F. Relation between M, F, U, M is equal to F by F minus U. Just take the final formula. Here also take this is minus v by u. Height of the image divided by height of the object is equal to, magnification is equal to height of the image by height of the object is equal to minus v divided by u. That also you take. Formula. Mirror equation will be 1 by v plus 1 by u is equal to 1 by f. Lens will be 1 by v minus 1 by u is equal to 1 by f. Magnification for mirror will be minus v by u. For lens, it will be plus v by u. Okay. So, anyhow, final, I'll give you a comparison. But over.
Yes.
Over. Did you just take the final formula?
Yes, sir.
Yes.
Okay. Take down that question, try to solve it. Over. A driving mirror consists of a cylindrical mirror of radius of curvature 10 centimeters and length over the curved surface is 10 centimeters. So what is your focal point? Focal length?
5
5
centimeters.
centimeters.
If the eye of the driver be assumed to be at a great distance from the mirror, that a field of view in radians is over. Useless question. Concave, right? I'll take it like this something. Just see. This is your radius of curvature. The height, length over the curved surface. So from here to here it is 10 centimeters. Right? So this is theta. Okay. If the eye of the driver be assumed to be at a great distance from the mirror, then the field of view in the radian is right. Now see, if you like that, the eye of the driver is at a great distance from the mirror, that's also like the parallel is. That's also no. The parallel is small focus.
Yes, sir.
So this is how much? This is how much?
And then
Theta is how much?
2 radians.
This will not be a complex mirror because usually what mirrors we have like side concepts also. Usually it is a concept or complex. So now we make some
They go like this, like this. That here could be coming from focus. What kind of mirror is this? Next.
Is it 10 centimeters?
I don't have to calculate. The object is beyond center of curvature, isn't it? So immediately
It will diminish.
hmm?
The size will reduce.
What is it?
The size will reduce.
Hmm. But the problem is there are two options which are less than the original one. See, what I will do is, okay,
So, isn't it at the center of curvature?
that's what I'm drawing the diagram, then you will understand. See, if this is my center of curvature, this is my pole, the object is placed something like this, right?
Yes, sir.
So let me take this as O dash. So this is your focal. This length is how much?
10 centimeters.
10 centimeters.
From here to here it is.
20
20.
centimeters.
And from here to here it will be.
10.
10.
Okay. Now see, what I will do is, since it is placed here, exactly this point will come this side, isn't it? Center of curvature, anything on center of curvature will exactly again come on center of curvature, isn't it?
Yes,
Yes,
sir.
sir.
This is beyond center of curvature, so what happens? It
It will
comes
go forward.
correct. So it will be something like this, isn't it?
Yes, sir.
But how we'll look at it? Now, what I'm going to do is, I'm going to use my Miller equation. 1 by V plus 1 by U is equal to 1 by F. Clear?
Yes, sir.
U is how much?
20.
Take this O dash first.
30.
30.
Your F is
1 by 10.
10.
So 1 by
So get me your image distance. Get me your image distance.
15, sir.
How much?
15.
10 now.
15, sir.
Minus 20.
Now
Yes, 15.
you will use your sign convention. U is minus 30 centimeters. F is minus 10 centimeters. Now calculate 1 by V plus 1 by
minus 15.
is equal to minus 1 by 10. So from this 1 by V is equal to 1 by 30 minus 1 by 10. Right?
Yes,
Minus
sir.
1 by 15. From this
V is
V
equals to minus 15.
minus 15 centimeters.
Right.
Right?
Million.
So this point, which is there, O dash, is at minus 15 centimeters from the pole. So from here it is at 15 centimeters this side, left hand side, right?
Yes, sir.
So what will be your other point at?
So the other
20.
point will
20 cm.
20 only, sir. Other point will be at 20 only.
Correct?
Yes, sir.
Yes, sir.
What is your length of the image?
5.
5 centimeters. Understood?
Yes, sir.
Yes, sir.
We have to still do velocity of your images in spherical mirrors also. Spherical mirror moving forward and backward, object moving forward and backward.
So
Then
do we just differentiate this equation now?
okay. Then we will take an area placed in front of a concave mirror. Then what will be the area of
So
the
you
image?
try and change in length and everything and then find area.
So those kind of questions are there. Okay, that we will do tomorrow. It's already 11:40 now. Okay. See, this weekend you have examined that schedule which they have given. Okay, waves or something. Clear?
Yes,
You
Yes,
have
yes.
to write and you have to write the exam. Because ray optics will take 1 month, I told you. Okay, and I don't know when they will give again ray optics for you in syllabus. Clear?
yes, sir.
Yes, sir.
Started ray optics, so this 1 month. The 1 month syllabus I've already completed. We have done hundreds of different models of questions in waves and wave optics, isn't it? Literally 200-page book is over for you.
Yes, sir.
So those many models we have done. So this 1 month you are on your own for that portion of the examination is considered. Anyhow, I will discuss the paper. Okay. Yes. So Tuesday to Saturday, I'll be taking the ray optics only.
Yes, sir.
Now you understood your sign conventions.
Yes, sir.
If you just take plus 30 instead of minus 30, your V changes.
It will be plus 15.
Right? Just take plus 30 here, take it that side. It will be minus of 1 by 10 plus 1 by 30. So it will be 40 divided by 300, 4 by 30, or reverse it, 30 by 4, 7.5. Understood? Hello?
Yes,
Yes,
sir.
sir.
See, where is 15, where is 7.5?
Yes, sir.
So you should be very careful, and every time you have to be cautious about your sign convention. Clear?
Yes, sir.
So tomorrow we will solve some more numericals on spherical mirrors. Okay. As such, do you have any doubt in today's class? What is linear magnification formula?
H dash by
Height of image by height of object.
Is equal to minus
Minus
Minus V by U.
minus V by U.
Sometimes it will not give you height of the image and height of the object. Sometimes it just give you object distance and image distance. Then you say, sir, you didn't tell us that formula. So when I say linear magnification for the mirror, you have to say it is hi by h naught or minus v by u.
yes, sir.
Mirror equation.
1 by V
By
plus
1 by V plus 1 by U
U
equals to 1 by F.
Your sign conventions you have to be careful.
yes, sir.
For magnification also sign convention should be taken, V and U. Clear? Because see, for a concave mirror, if you take magnification minus V by U, it will be minus of minus V divided by minus U, isn't it? So it will be plus V by minus U, again minus V by U. So magnification negative means your nature of the image is
Real.
real. Okay. If you take your convex, object distance is negative, image distance is positive, right? So magnification will become minus V divided by minus U. So minus minus gets cancelled, it is V by U. So magnification is positive. So your image is
Virtual.
Image.
virtual image. Okay.
Yes, sir.
If you have any doubt in this, in your formula book, you can take it down. Concave, M is equal to minus of minus V divided by minus U, which sign convention. I'm not telling which sign conventions because anyhow you have to take sign convention. Clear?
Yes, sir.
Any doubt into this class? No. Okay, then I'll see you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you.